So you're sitting at home alone on a dark Saturday night. You're scrolling through the TV guide to see what's playing. You see on Chiller, Night of the Living Dead is playing. So you're like, oh, a classic zombie movie. So you start watching it. And you get to the part in the movie where all the zombies are breaking into the house and going after the people. And then you hear a creak down the hall. Was it footsteps? Or was it just the house settling? Then you ask yourself, what if it is the zombies? But that raises an interesting question. Is the zombie apocalypse actually possible? Well, let's talk about the science behind that.
Welcome to The Science Behind That with Atticus Hamilton.
Hello, all you scientists, and welcome on back to The Science Behind That podcast. I'm your host, Atticus Hamilton, and as you heard in the intro, today we're going to be talking about zombies. We're going to be talking about zombies and if the zombie apocalypse is actually possible. This was supposed to be one of my October episodes, but because I wasn't here for the entire month of October, we're now doing all my October episodes in November. So extra month of Halloween, which I know if any of you guys are like me and Halloween is your favorite holiday, that should be good news. But today we're going to be talking about zombies, and as I said, if that's actually possible. And so we're going to be discussing media. So we're going to be discussing how various types of media portrays this idea of zombies. We're going to be talking about where that idea first came from, where it is now, and then out of those ideas, what is most logically plausible. And then, of course, we're going to finish with, creating our own zombie apocalypse pathogen and how that would theoretically work. And spoiler alert, it is theoretically possible, but it is unlikely. And it would not be zombies in the sense of George Romero style zombies. So, ladies and gentlemen, before we jump into today's episode, I'd like to invite you all to go grab yourselves a nice steaming hot cup of coffee, add a little bit of maple syrup to it, and we will jump right in. So, zombies. Zombies have been a part of culture for some people for a very long time. The first idea of zombies really came from both a movie called White Zombie in 1932 and also the work of George Romero. George Romero is generally considered the father of the whole zombie thing, the whole zombie culture, zombie media, with his movie Night of the Living Dead. Now, that is a cult classic, black and white. If for any of you listening to this that haven't seen it, I'd definitely go watch it. It's really good. And then his films after that, such as Dawn of the Dead, Day of the Dead, Land of the Dead, Diary of the Dead, they all were built on the same idea and the same universe, basically. But with George Romero, his zombies were resurrected corpses, and very little explanation was ever put into why they were resurrected in the first place. Across his film history, there's like little mentions of maybe it was radioactivity or an exotic bacteria on an asteroid from outer space, but generally speaking, there was very little explanation of what causes them. And a big distinction in George Romero's films to modern zombie movies is that you didn't actually have to be bitten by any of the zombies to become a zombie. Anybody that died, regardless of how they died, as long as their brain was intact, their body was resurrected as a zombie. Sorry, I had to take a sip of my coffee here. But that's kind of interesting too. But from that, basically, most of the modern films, modern zombie movies were born. Now, there are examples of, and I'm using air quotes, real life zombies here, particularly Haitian voodoo zombies. And I will talk about that in a little bit here. But for the most part, you know, as we all know, the zombie apocalypse hasn't happened yet. But after George Romero's films, then you had things come along like the book World War Z, which was built upon a similar idea of resurrected corpses. But for the book World War Z, the person had to be infected with the Solana virus, which killed them and then resurrected them. You had Night of the Living, or not Night of the Living Dead, Walking Dead, which was a similar idea of resurrected corpses that were infected by this virus. And so you had media like that stuck closer to the George Romero-esque style of zombie. But what we started to see as well is, since then, it seems like more and more people are trying to make it more realistic, trying to explain a theoretical way that a zombie could happen. So let's discuss some of these. So the most popular idea is rabies, right? A modified rabies virus. And this concept has been used in the movie World War Z, not the book, but the movie World War Z. It was used in 28 Days Later, 28 Weeks Later. It was used in the movie The Crazies, which is a very good movie. But that raises the question, you know, in reality, would rabies ever mutate to cause any of those disease-like representations we've seen in that media? And the simple answer is probably not. And by probably not, I think there's like a 99.9% chance it wouldn't. And let's talk about why. With rabies, there's a misconception. And the misconception is that the symptoms it causes in dogs and other canines of, you know, hyperaggression, biting everything it can, it causes in people. The reality is it does not cause those symptoms in people at all. First off, the incubation period of rabies in dogs is 10 days to a year. In humans, it's like 4 months to a year and a half. So the incubation periods are significantly different. In dogs, what you see happen a lot is the hypersalivation and hyperaggression. The hyperaggression is to bite anything that the dog can, and the hypersalivation is because the rabies virus replicates in the salivary glands. So in dogs, the rabies virus replicates in two places, the brain and the salivary glands. In the brain of the dog, it upregulates aggression and it hyper-upregulates aggression. And along with that, because the virus spreads through biting, it also replicates in the salivary glands, which results in the virus also upregulating saliva production, which is where the hypersalivation comes from. In humans, humans don't have hypersalivation because the virus does not replicate in the salivary glands. Humans, the virus strictly replicates in the brain and the spinal cord. And in people, what you have really is you just have severe encephalitis of the brain, of the spinal cord, and severe meningitis of the brain. And, it also causes very, very severe muscle spasms, which is where the fear of water comes from. So as I'm sure many of you have heard before, people say, being afraid of water is one of the big signs of rabies. It's not that if you walk up to a lake and you have rabies, you're like, oh my God, it's terrifying. What it is you're afraid to drink anything because when you swallow, when you have symptomatic rabies, it causes very severe muscle paralysis in the neck and muscle spasms, which is exceptionally painful. And so as a result, patients who have rabies don't want to drink anything, they don't want to eat anything, and they end up drooling a lot because they don't want to swallow. Because by swallowing, that causes severe pain from the muscle paralysis in their throat. Sorry, I had to take a drink of my coffee. And so in humans, rabies is pretty much 100% fatal. It's a death sentence. Once you develop the symptoms of rabies, that's it. Similar in dogs, but humans are a dead-end host for rabies. And they're a dead-end host because the virus cannot spread person to person with rabies because it does not replicate in the salivary glands in people, and it does not cause hyperaggression in people. So therefore, to make the virus do what we see in those movies, like The Crazies, like World War Z, 28 Days Later, the virus would have to start to replicate in the salivary glands and downregulate higher cognitive processing and upregulate aggression. Because that's the thing is, I know a lot of you out there are dog owners, but dogs aren't that smart. And when it comes to viruses especially, and infections of the brain, the virus in the dog doesn't have to suppress cognitive processes that tell the dog, don't bite that guy, it's not socially acceptable, right? It just has to make him aggressive because there'd be no conflicting cognitive process. In humans, because we have significantly higher levels of cognition, the virus would have to downregulate the action of the frontal lobe and upregulate the action of the amygdala. And so let's jump into that then. So World War Z, as we see in the movies, it'd be unrealistic for a virus. Night of the Living Dead and all of the George Romero films are generally very unrealistic because in humans, we don't really have diseases that reanimate a dead corpse. And the crazies, again, it'd be unrealistic to be rabies. And the other aspect of this as well is rabies doesn't mutate that much. It is a double-stranded DNA virus, which means that it uses the proofreading enzymes of the host cells, which makes sure that there's no errors in replication. So as a result, it's a very stable virus, and it's not very prone to mutation, unlike the flu, unlike other single-stranded RNA viruses and double-stranded RNA viruses. But talking about this, how would you theoretically create a zombie? Well, as we talk about this, I'm going to mention Haitian voodoo zombies. Now, some of you out there, some of my audience out there is from Haiti. And so if I get anything wrong about this, I'm sorry. I'm trying to just do a very simplified explanation. I know that zombies in Haiti have a deep spiritual and cultural folklore significance, but for the sake of this episode, I'm just going to be talking about the science of how it works. So in Haiti, there are zombies, but they're not reanimated corpses. Instead, they're normal people who've had things done to them to where they obey commands. They do not really talk. They don't have a personality anymore. They have altered behavior, loss of memory, significantly reduced cognitive function, and free will. So they're able to just be commanded. Now, there are religious aspects of this where it's believed people use dark magic and sorcery to create this. But what is for certain is that historically, when these zombies have been created in Haiti, they've used toxins like tetrodotoxin. Tetrodotoxin is a toxin from pufferfish, and in this process, they give the tetrodotoxin to a person, and it it zombifies them, and I'm using air quotes. What it really is it's chemical lobotomy. So we've talked about lobotomization before on this podcast. I've talked about it, I think, 2 years ago on my Halloween episode of the science behind that. I talked about the history of lobotomies. I talked about where they came from, all of that stuff, how it works. So if you wanna listen to that, I'd definitely go and listen to that Halloween episode from 2 years ago, I think. I'm trying to find it here. Yeah, 4 years ago. Holy cow. Yeah, so on my Halloween special, October 31st, 2020, I talked about lobotomies and the actual specifics of it. But ultimately, the Haitians' voodoo phenomenon is chemical lobotomization. The tetrodotoxin destroys the frontal lobe, and that renders the person as basically that, they can breathe and they can understand language and that stuff, but they can't really think for themselves. So they're able to be commanded and to do certain tasks. And there's a lot of other aspects of this in Haitian folklore that I'm not going to get into, but ultimately that is an example of real life zombies, and I'm using air quotes, but of course real life zombies, not in the George Romero sense, but in the sense of they are people that are unable to think for themselves, that don't have their own personality, that just follow commands willy-nilly. And when we talk about the history of zombies, pretty much that's where the idea first came from, is the Haitian zombie phenomenon. That was really the first one to put this idea of zombies on the map, especially with the film White Zombie in 1932. And the Serpent and the Rainbow in 1988. But so then when we talk about a disease, how would you make a zombie? Well, you would need to downregulate the action of the frontal lobe. Unless if you didn't do that and you just upregulated the amygdala, you would have most likely something familiar to the Crazies. In the movie The Crazies, if you haven't seen it, the disease that they were infected with was a bioweapon. It was genetically modified rabies. And ignoring that, basically with them, they still had all their cognition and personality, and they didn't want to bite anybody, but it turned them into homicidal maniacs. And so theoretically, you could super upregulate the amygdala, which controls your fight or flight response, and anger. So you could theoretically upregulate that, and if you didn't downregulate the frontal lobe, then and if you didn't replicate in the salivary glands, then theoretically you'd have a crazy scenario. But to create something more like 28 Days Later or the movie World War Z or any of those more typical zombie films where there are people that are infected with the disease and they bite people to transmit the disease, you would need to downregulate the frontal lobe, upregulate the amygdala, theoretically, upregulate the amygdala, replicate in the salivary glands, stimulate the muscles of mastication, which are your chewing muscles, and act on the specific areas of the brain that are correlated to biting and chewing. And that would theoretically create somebody that is detached from oneself with an anger and urge to bite something or someone. Now, how would you do that? That's the question, right? And we're going to get into that, but before we get into how you would do that, I want to first talk about is it possible then to do a George Romero style zombie? You know, the traditional idea of a reanimated corpse. And to answer this, we have to look at examples of diseases in the natural world that cause or that reanimate corpses. And some of you may be thinking, oh, Atticus, there's no diseases that reanimate corpses. Actually, there is. There is an entire family of organisms that when they infect their target species, they kill the organism and reanimate its body. And some of you know exactly what I'm talking about. Yes, that is right. It is the cordyceps fungus. So cordyceps is a very large family of fungi. There are a variety of different species of genus. There are a variety of different species of cordyceps fungi that are all in the genus of cordyceps. There are some that infect ants. There are some that infect beetles and tarantulas and spiders and praying mantis. There's a variety of different cordyceps that infect insects and arachnids. Now, how do they work? Most of them, when they infect an insect or an arachnid, they kill the arachnid or insect, and then they take control of its body and move it. They move its musculature. So there are examples of beetles that have been infected with cordyceps, and their abdomen is completely obliterated, but they're still moving around. Now, how does this work? Well, the muscular system of ants and insects and arachnids is relatively simple. There's only really a few muscles in their bodies that control their movement. And so what happens is the fungi takes control of the brain of the animal, and it sort of, and I'm using air quotes, it sort of keeps the brain alive and it kills the rest of the host, and it secretes neurotransmitters that still act on the muscles to move, and it moves the organism, and that's how it works. And then once the fungi has killed the host and has moved it to where it needs to go, then it stops moving the host, and the fruiting bodies sprout out of the host and release their spores. And many of you know about The Last of Us, and The Last of Us was built upon the idea of a cordyceps fungus, which is kind of cool because it's a novel perspective that before that, nothing else really took that approach. But there's some problems with it. The first being the very reason why the cordyceps fungus kills the host, which is fungi and fungal infections tend to have a hard time in immunocompetent hosts. And what that means is host organisms with a very strong immune system, immunocompetent. And they tend to prefer hosts that have immunocompromised immune systems. And that's why with people who have HIV, we often see oral thrush or oral candidiasis, which is infection with candida in the mouth because they're immunocompromised by the HIV. So in people, many of the fungal infections we see happen in patients that are immunocompromised. That could be because of another simultaneously occurring infection. It could be because they're old, or they're cancer patients, or they're on certain medications. Whatever the reason, we tend to see it in immunocompromised patients. There are some exceptions, but for the most part, that's what we see. And so, when we look at cordyceps fungus in insects and arachnids, it kills the host because a dead host does not have a functioning immune system. So if the immune system is not functioning, then there's nothing to stop that pathogen from taking over the body of the host. So when the ant that's infected with the cordyceps is moving around and then clamps down on the leaf, it's really no longer Mr. Ant. It's pretty much now Mr. Fungus, because the fungi has controlled its body. And with the ant will climb up to, or the fungus will make the ant climb up to the top of a leaf over the colony, bite down on the leaf, and then the fruiting bodies will sprout out of the head, burst the spores, and infect the entire colony. And so when we're looking at The Last of Us, in The Last of Us, this cordyceps fungus does the exact same thing. It kills the host, and it takes over the entire body of the person, and the fungus is controlling the motor movement. That would be exceptionally difficult for anything to do. And it's more realistic for a fungus to do this, because fungus are colonizers. And as we see in The Last of Us and the Resident Evil series, the fungi completely invades and controls the human's body, the host body, and makes it do what it wants. This would be exceptionally difficult. For a cordyceps to do that, number one is it would have to mutate to where it could even infect humans. Humans are high body temperature organisms, which is a very good adaptation because it basically prevents fungal infection. Most fungi are psychrotropic, which means they are cold-loving organisms. Now, of course, there are some exceptions, but the reason why humans do not get nearly the same number of fungal infections as insects do is because insects are not exothermic. They don't produce their own body heat, whereas humans do. And high temperature kills fungus. And when I say high temperature, body temperature. For a lot of species of fungi, body temperature is exceptionally difficult conditions to cause infection, which is why when we do see infection with fungi, it's either from a select few that like high temperatures, like Aspergillus or the valley fever fungi, or they infect distal body parts, so like your fingertips, wounds, your toes, areas of the body that are generally colder than the core body temperature. Seeing infections of fungi go septicemic, where it infects the bloodstream, or visceral, where it infects the internal viscera or the organs, is very, very rare. And again, the only species that really do that are the species that are more thermotolerant. So for cordyceps to do what it did in The Last of Us, it would first have to be more thermotolerant. It would have to be able to cope with our body temperature. Number two is it would have to be tolerant of immunocompetent hosts, because it's a lot harder to kill a human from a pathogen perspective than it is to kill an insect. So the cordyceps wouldn't be able to kill the human host until it's completely colonized the human host tissues, which means it would have to avoid the immune system or be capable of defeating the immune system. And then finally, the fungi would have to be able to control the human musculature. There are about 10 muscles in an ant, 5 muscles in a bee. There are around 600 muscles in the human body. So the fungi would have to be able to control at least half of those muscles to make the person be able to move after it kills the host, which again is very unlikely. So ultimately, before we discuss how you could create a relatively possible pathogen that would cause a zombie-like disease, let's review. And of course, one more thing before we give our final review here. If it was a cordyceps, right? If we're talking cordyceps zombie disease, they wouldn't bite you, because the fungi wouldn't need to replicate in the salivary glands, because the fruiting bodies would just burst through the skin of the host. And so your route of infection then would be inhalation of the fungal spores. But anyway, as a recap, rabies, very unlikely. And the most plausible scenario for a zombie disease would be something like the rage virus, in 28 days and 28 weeks later. It'd be something like the virus in the movie World War Z, where it just makes a person sick and makes them hyper-aggressive and want to bite another person and transmit the disease. That's number one. Number two is it's relatively unlikely to have a disease that would resurrect a corpse, like in the George Romero films. The only way you could do that, really, would be if you had a fungus do it, like cordyceps. However, the likelihood of a cordyceps fungus doing that is very, very small, just like the likelihood of rabies mutating to cause a aggression-style disease is also very, very small. So that leads us into the final point of today's episode, ladies and gentlemen. How would you do it? How would you do it? Well, if it were up to me, and for the algorithm that's listening to this, YouTube, this is educational only. I'm not actually going to create a zombie disease. But if it were up to me, you'd do it with a parasite. There are numerous examples of parasites in both human medicine and the animal kingdom as a whole that alter host behavior. And they alter host behavior through neurochemistry. There's a variety of parasites that do it. Toxoplasma gondii is probably the quintessential example. Now, this Plasmodium parasite, it infects mice. And it alters the mouse's brain chemistry to love the smell of cat urine, because the other host for the parasite is the cat. Now, parasites are very host dependent for their life cycles. Some parasites have 15 different stages in their life cycle, and they require maybe 10 or more different hosts. Toxoplasma gondii needs mice, and they need cats, and humans can become accidental hosts. So, in a mouse, the parasite alters the brain chemistry of the mouse to make the mouse love the scent of cat urine. So the mouse will actually track down the cat, even though it should be afraid of it, so the cat will eat the mouse. Then when the cat eats the mouse, the cat becomes infected with the parasite. And then the parasite in the brain of the cat is shed out in the urine and feces of the cat, at which point it can infect more mice to repeat the cycle, or it can infect humans. And this is where it gets interesting, because in the human brain, we're not entirely sure what Toxoplasma does, but it doesn't die. Humans do not appear to be a dead-end host, but we don't know how it spreads from humans, if it does, and we don't really understand what it does in the brain. But on CAT scans and MRIs, we can see the parasite in the brain of people. Now, there is some preliminary research which suggests that it upregulates certain hormones in the brains of people to make them more passive, to make them feel happier, and again, more passive, less likely to be confrontational. But there's also research to suggest that the parasite makes people act more aggressively. So we don't really know what it does in the human brain, but we do know that it does regulate human behavior, and it does modify animal behavior. There are parasites that infect slugs' brains to make their eye stalks pulse multiple colors, to where then birds will see this, think it's a grub, and eat the slug, because it'll also make the slug climb to the highest point to where it can be seen by birds. So how would this apply to zombies? Well, all you would need to do would be have a parasite that secretes a toxin that destroys the frontal lobe, number one. A toxin similar to that of like tetrodotoxin and pufferfish, like we've seen with the Haitian zombies, the Haitian voodoo zombies. So that's number one. Number two, it would have to produce dopamine or any other accessory neurotransmitter to upregulate the activity of the amygdala to cause hyperaggression. And number 3, it would have to replicate in the salivary glands, or the parasite would shed its eggs in the salivary glands and then upregulate activity of the brain, inducing biting and aggressive behavior that way. And theoretically, that is entirely possible. Now, are there any base organisms that you could use out there to do this? I don't know. I'm not sure if we've discovered those pathogens yet. But it's this exact idea which is the basis of the Neurax worm scenario in the game Plague Inc. And if we're looking at the most plausible scenario for zombies, it would be a parasite like the Neurax worm. Because parasites, we know, modulate host behavior more so than any other group of infectious agent. More so than fungi, more so than bacteria, and certainly more so than viruses. So, ladies and gentlemen, I hope you enjoyed today's episode. It was a lot of fun for me to do. I love these, I love episodes like this where we talk about popular culture and brainstorm various scientific phenomena. So I enjoyed this. I hope you guys did as well. And if you have any ideas for what parasites would work for this, definitely shoot me an email or send me a text message using the link in the description below. And of course, do the same thing if you have any topic suggestions for a next episode. Ladies and gentlemen, thank you so much for listening to the Science Behind That podcast. Have a fantastic week, and I'll see you all on Friday. And remember, as always, stand up and question everything.